I'm going to go over how to calculate the enthalpy of a reaction utilizing the enthalpy of formation. You guys should have gotten a chart that has common compounds and their enthalpy of formation. So this is just when these compounds are formed, what is the energy involved? So here is the equation. We have that the enthalpy of the reaction is equal to the sum, that's what this sigma means, the sum of the enthalpy of formation of the products, and this N here just represents the number of moles of each species on the product side times their enthalpy, minus the sum of the reactants. And again, it's the enthalpy of formation of that species of reactant times the moles from the balanced equation. Okay, so it makes much more sense when you actually do an example. So down here in my example, I already have the balanced equation. Okay, they've already given me the enthalpy of formation for the compounds necessary. Okay, notice that there is not a enthalpy of formation for oxygen. Okay, and the reason for this is because it is a pure element, even though it is a diatomic element, because we have two of them. It's still just a pure element. There's no other element in there making it a compound. All right, so these two questions, they ask what are the products. So here's our products, and then our reactants are on the first half of our equation. Okay, and then here I kind of already addressed, but my enthalpy of formation for oxygen is just going to be 0 because it is a pure element. Okay, so I have the very basic structure of what we're going to do for the enthalpy of the reaction, but I'm going to go ahead and write it out again. So I have my enthalpy of the reaction is equal to, and I'm going to do my products. Okay, so I'm going to do the number of moles of my CO2, which is 3 times the enthalpy of formation for CO2, which is negative 394. Okay, and actually I'm going to put all of this in brackets, my product side, plus, because it's the sum of, plus 4 times the enthalpy of my water formation, which is negative 286. Okay, minus my reactants, and I'm actually going to skip down just because I'm not going to have enough room to write all of my reactants in. So on my reactant side, I have 1 mole of my C3H8. So I'm going to do 1 times the enthalpy of formation for that compound, which is negative 105. Okay, and then plus my other species, which is oxygen, which would be 5 times 0. So that's just going to be 0. Okay, so then all you do is you add or multiply the different parts in here, add them together, okay, and then do your total subtraction.